Great to see you here. My name is Luc de Ceuster. I'm founder of the Ceuster Academy. Welcome to my YouTube channel. If you didn't subscribe yet, this is the moment to click the subscribe button, click the bell button, and every time we have a new video for you, YouTube will inform you. In this new video, I will continue with the topic of computer arithmetic with large numbers. Like I said before, when numbers become large and we have additions and multiplications, we can have data overflows. And in order to avoid that, we showed a technique how we can use n-tuples and the Chinese Remainder Theorem to find those multiplications in an easier way. In our new exercise, I'm going to multiply the numbers 755 and 299. We're also going to add those two numbers. They're still small numbers, but it makes it easier to show you how the principle works, because the principle is the same whatever the numbers are. But also we know in computers that they are really good at operating with numbers up to 100. And what we're going to do is to select the moduli to be 99, 98, and 97. Those three numbers are, in fact, relatively prime. So their GCDs is equal to 1. And when we look at the multiplication, when we look at the Chinese Remainder Theorem, we know that M is M1 times M2 times M3, and this number will be used later in the calculations. But let's first start with finding the n-tuples. The n-tuples for A and B. In this case, n is 3, so basically we can say that there are the three tuples. The first three tuple for A is in fact 755 modulus 99. Then we have 755 modulus, oh, that's one too much, modulus 98, and we have 755 modulus 97. I'm sure you know how to calculate those moduli, so we just have to say 755 is equal to a k factor times 99 plus a remainder, and that remainder is 62. For 755 modulus 98, the number is 69, and for 755 modulus 97, the remainder is 67. Now we have the three tuple for B, which is 299. So we have again here 299 modulus 99, which gives us 2. Then we have 299 modulus 98, which gives us 5. And finally we do the same for modulus 97, and 299 modulus 97 is equal to 8. So basically what we have here, we have the three tuple for A, the three tuple for B, and when we're going to work, when you're going to calculate the addition and the multiplication, we have to use those n-tuples. Let's first look at A plus B. So we have the n-tuple here, 62, 69, and 67, plus the three tuple of B, 2, 5, and 8. And we find that the n-tuple, or the three tuple for A and B, A plus B, is 67. We have 74, and then we have 75. So that's the first three tuple that we're going to use to find the result A plus B using the Chinese Remainder Theorem. Now when we do this for A times B, so now we have 62 times 2, we have 69 times 5, and we have 67 times 8, which gives us in order 124, The second one, 69 times 5 is 345. And the last one, 67 times 8 is 608. Now we have to bring them back to modulus 99, 98 and 97, which gives us 25. Then we have 51 and 26. You can find those easily. You can stop the video and do the calculations if you don't find the number. It's just the modular arithmetic that we've been doing before. Now we have the n-tuple or the 3-tuple for a plus b. We have the 3-tuple for a times b. Let's now find the result by using the Chinese Remainder Theorem. Let's first continue with addition, and we found the 3-tuple for a plus b is 64, 74 and 84. And we can write this now as a set of linear congruences. The first linear congruence is x is congruent with 64 modulus 99. Then x is congruent with 74 modulus 98, sorry for that, 98, and then x is congruent with 84 modulus 97. So basically we have the conditions to resolve this using the Chinese Remainder Theorem. There is one unique solution because the three divisors are relatively prime. Now the first thing to do is to find m, big M, which is 99 times 98 times 97, which is equal to 941,094. Now we can calculate big M1, which is m divided by m1, which is equal to 9,506. M2, we find m divided by m2 gives us 9,603, and the last one, m3, is big M divided by the 97, which gives us 9,702. Based on this and applying the Chinese Remainder Theorem, we have to find the xi's with following equation. Xi times mi is congruent with 1 modulus mi. So we're going to do this for m1 and x1, x2 and x3. So we have m1, it's 9,506 times x1 is congruent with 1 modulus m1. m1 is 99, so we have 99 here. Then we have the second one, which is 9,603 times x2 is congruent with 1 modulus 98. And the last one is 9,702 times x3 is congruent with 1 modulus 97. Basically what we have here are those equations to resolve, and we have to find the modular inverse. Now the first thing we can do is to simplify here, because we can write 9,506, it's larger than 99, so we can find the remainder of 9,506 divided by 99, and this is equal to 2. You can do the calculation and find this very quickly. 9,603 divided by 98 gives us a remainder of 97, and 9,702 divided by 97 gives us a remainder of 2. Now when we look at it, 2x1 1 modulus 99, we can find the inverse very quickly. Because we see if we multiply 2 with 50, we find 100. And 100 divided by 99 gives us a remainder of 1. So basically we can say that x1 is equal to 50. Now for the other ones it may be a little bit more complex. There are different ways to find this. And when we do the calculation, you can do this calculation on your own. We've done that already a number of times. And when we have 97, 98 here, well, we have to multiply x2, or we have to select x2 equal to 97. So 97 times 97 modulus 98 is equal to 1. So x2 is equal to 97. And we can do the same for the last one. 2 times x3 times 97. Well, when we look at 2 times 49, 2 times 49 is 98. 98 modulus 97 is 1. So we have x3 is 49. We found B1, B2, B3, M1, M2, M3, x1, x2, x3, and now we can find here the solution, which is x is equal to the sum of I equal to 1 till 3, bi times xi times mi modulus m. So we'll find this solution. We will do that on the next board. I will clean the board, and we do that again under the form of the table like we did before. We completed the calculations and now we put everything in the table. So in the column of B, we find the 3 coefficients from the Chinese remainder system. So the system of linear congruences, 64, 74, and 84. We found xi, x1 50, x2 97, and x3 49. And the coefficients mi, 9506 for big M1, 9603, and 9702. And what we have to do now is to multiply those. Now you will see the numbers become immediately a lot bigger. And for the first one, we find 30,419,200. For the second one, when you do the calculation, you will find 68,930,000 and 334. And for the last number, when you multiply 84 with 49 and 9,702, you find 39,933 and 432. When you add all of them, you find 139,282,000 and 966 modulus m. M being 941,000 and 094, that's m. So basically we can say that 139,282,966 modulus, or is equal to, we don't have to write the modulus here, we say this is equal to 133 times 941,094 plus 1,054. And that is in fact A plus B. So when we take the original numbers, we will see that we find this number. Let's now have a look at the solution for the multiplication. And based on the fact that we already know mi's, the xi's, the only thing we have to find are the coefficients here, which are in fact the elements of the n-tuple. Let's do that and let's find the solution for a times b. When we look at the multiplication of a and b, we did the same like we did before. We determined the three tuple that represent a times b, which is 25, 51, and 26. And based on this, we can create, in fact, the three linear congruences that are part of the system that we have to resolve. So first of all, we have x is congruent with 25 modulus 99. We have x is congruent with 51 modulus 98. And the last one, x is congruent with 26 modulus 97. So basically what we have to do is to change the coefficients that I had here from the previous equation, and we just have to change it with those new numbers. So we have here 25, we have here 51, and here we have 26. The coefficients x1 are obtained in the same way, so we already found them in the previous part. We don't have to do the calculations again, and we can recuperate those numbers. So we find x1 is 50, x2 97, and x3 is 49. The same is valid for m1, m2, and m3. And now when we multiply them, we find, in fact, for the first one, 25 times 50 times 9,506, 11,882 and 500. For the second one, 51 times 97 times 9,603, we find 47,506,041. And for the last one, 26 times 49 times 9,702, we find 12,360,000 and 348. When we add them, we find finally 71,748,889 modulus m, and m is 941,094. So that's basically n. Based on this, we can say that 71,748,889 can be written as 76 times 941,094 with a remainder of 225,745, which is a times b. Since these are relatively small numbers, we can verify the result very quickly using a normal standard calculator. So that's what I wanted to show you, how to deal with large numbers, how to use the computer using the n-tuples and the Chinese Remainder Theorem. That was the end of this video. Don't forget to have a look at the text below. You find links to our courses. There is a coupon for every course that will give you a great discount. And if you didn't subscribe yet, this is the moment to click the subscribe button, click the bell button so that whenever YouTube sees that we have a new video for you, you will get the message. That was it. See you later. Bye bye.